use saved user default settings, use systems from a model file, and use built-in settings. We'll go with the use built-in settings, more customizable. We'll select the units we want to begin our project with, metric SI. We'll select the region. Region is India. We'll select the steel section database, again Indian. You can see all the options are available. Next is the steel design code. We'll go with IS 800-2007. That's the Indian. You can see all other design codes are also available in the ETABS. And the last one is the concrete design code, which is IS 456-2000. Again, you can see if you select any other region and for the materials, you will have accordingly the database for every code. So once we have selected all of this, we'll press OK. So the next dialog window is basically starting the first step of your project. It is to define your project, the basic definition, how your grid will look like. And it also offers some pre-templates which you can use. So for the templates, if you'll see on the bottom, add structural objects, you have few options available. First is the blank. Second is the grid, which we will be working with. Then you have steel deck, staggered truss, flat slab with perimeter beams, waffle slab, and two-way or rib slab. You can select either of these if you want to begin them with. It's just a template. It will ask you basic things for the template and produce the model for you. So let's start with the grid. We'll make the model from scratch. Now the first one is the uniform grid spacing. So the grid will be divided in two directions, X direction and Y direction. And our aim is to draw a grid on every intersection of the beam column junction. That is our aim as engineer. So let's start with the grid dimension. It says number of grid lines in X direction, number of grid lines in Y direction. That is free. Select. We can make it any. Let's change it to 5. Then spacing of grids in X direction. It means if there are say 5 grids in X direction, 1, 2, 3, 4, 5 means the spacing between 1 and 2, 2 and 3, 3 and 4, and so on. So we will say 6 meter. Similarly goes for Y direction. You will start with 6 meter. Now the next is the story dimensions. So here we will define number of stories that will be in our structure. We will define the typical story height, and we can also define a bottom story height differently. All of these values are editable once we have defined them in the model. So let's start with number of stories 3. Typical story height, let's keep 3.3, and bottom story height also let's keep 3.3. We'll press OK. Now you can see on the screen, we have 3 windows open. The first one is the Model Explorer. So through Model Explorer, you can access different things in your model, in your structure. You can access the structure layout properties. You can access stories, grids, you can access the properties, materials you have defined, frame sections, tendon sections, if there are any slab sections, and so on. Then you have the structural objects to access of the different stories. It is up to you if you want to use the Model Explorer to explore through the ETABS or not. So we'll close this for now. Now on the screen, there are 2 windows left. On the left hand side, we have the plan view of the grid we just defined. And on the right hand side, we have the 3D view of the grid. You can see. If you click on this button, rotate 3D view, you can rotate your grid and see. So one more thing, when you have multiple windows open on ETABS, you can open as many windows as you like. There are 2 as of now. If you go on the right hand side and see this small drop down arrow, you can add another window. So now there are 3 windows. So if you are working on 3 windows, the correct way to identify on which window you are, so any changes you apply will be applied to the window only. For example, if I'm working on the 3rd window, for me to know if I'm working on the 3rd window, I'll click on a blank screen anywhere, and this part, this 3D view will be slightly highlighted. For example, if I want to go on the 1st window, you can see plan view story 4. I click somewhere on the blank space. Now you can see the color is changed. This will help you identify on which window you're working for. So we'll go with 2 windows as of now. So on the extreme left hand side, you have some shortcuts available, which we will discuss as we go further. So coming to the top, we have file, edit, view, define, draw, select, assign, analyze, display, design, detailing, options, tools, and help. So this is in a specific order as you progress in your project. So for the file function, you open a file, you can close it, you can save, or you can import or export any drawing. For the export, you can export this file to an E2K file. That is the text file of this model. You can send the ETABS database as an XML file. You can export the file to a save file to do the foundation. You can also export them to the Revit file. Similarly, then if you want to take a printout of your model, you can do that. To take a printout, you'll just go to print graphics and you can see how the model is displayed. So you can use your mouse middle button and you can drag this model and fit it inside the paper, inside the boundaries as per your convenience. You can edit these things also. If you want to change any label on the drawings, you can edit anything. It's all customizable. Then you can give the print command. So then next, coming to the edit. So the edit option helps you edit your grids, your frame objects, your shell objects, or any object you have drawn inside your model. So you have basic functions for the model: undo, redo, cut, copy, paste, delete, and everything. Now the small, quite important one is the edit stories and grid system. We just defined stories as a template and a grid system as a starting step for our project. So under this, you have two options available again. First one is the story data. If you click on modify show story data, this will show you your current story data, which you just defined. So you have 4 stories. It shows you the height, it shows you the elevation of every story, and it shows you if it is similar to any story or not. So these are also all customizable. For example, let's start with renaming our stories so that it direction. Now, say if you want to add another grid line, or say if you want to modify the dimensions of the grid line, say if you want to first work on the x direction and you want to change the distance between A, B and C and D and so on. So under this rectangular grids, there are two options to display the grid. So first is the display grid data as ordinates, and the second is display grid data as spacing. So when you're working on changing the dimension of the grids, it is recommended you use display grid data as spacing. So this shows you the spacing between the grids. So for example, so we are working on X grid. So if you want to change the distance between B and C and D, you just go there, change it to 5, and that's it. Very simple. Similarly, on the right hand side, we have the Y grid data. We'll change the values for this also. And you can see the changes are being reflected on the top right, where the grid layout is shown. If you want to add another grid, you can simply come to X data. You will click add, and it will add another grid. We'll add the distance between them also. And if you want to delete this grid, you'll just click on F and delete. This will keep reflecting you any change you make. You'll press OK, and you can add another grid system here also, and you'll press OK. Now we have the refresh grid available in front of us. So we'll start with the ground floor. So next edit option, you have replicate option, which we will explain later. You have merge joints. You can play with joints. You can align them, move them, and you can move your frames or shells if you want from one place to another. You can edit the frames. You can divide the frames into multiple parts, or you can join the multiple frames. For example, if you have a beam, that is that if you want to divide a beam on the column, you can just select the frames and divide frames. And similarly, you can edit the shells. So next is 3D view, which is open on the right side of the window. We have the set plan view, which is open on the left side, on which we are working on. Then you have the elevation view. If you want to see any elevation, for example, if you want to see the elevation along the grid B, we'll simply select B and press apply. You can see the elevation there. We'll switch to plan. You can select which plan you want to see. Roof, second, first, ground. We'll press OK. We have the ground floor plan in front of us. Going back to the view, there are set building view limits. For example, if you have something specific you are working on and you want to see some inside the floor and you want to set it just you want to set the viewing option just to the first floor, you'll select the bottom story as first and you select the top story as first and press OK. Now it will just show you first story. Next, we have the rubber band zoom. Rubber band zoom is simple. You draw a rubber band like this thing and it will zoom you there. So next is, now we are starting with the project. Now the first step to start the project is we start with defining the material we want to work with. We'll go with material properties. Now you can see in the starting, we defined our region for materials Indian, and we also defined the concrete and steel code that we will be using. You can see ETABS has predefined some materials for you. We have Fe345, M30, HYSD 415 and a tendon. If you select Fe345 and click on modify show material, you can see the properties of the material. You can see the density, you can see modulus of elasticity, Poisson's ratio, coefficient of thermal expansion. All of these can be edited as per user's convenience if he or she wants to make any change. This is the basic standard property of Fe345. You can also click on modify show material design property data. You can see the minimum yield stress, again customizable, minimal tensile strength FU, expected yield stress and effective tensile strength. Next, we have the M30. We'll click on modify show material. You have the material name, material type concrete. You have the density, modulus of elasticity, Poisson's ratio, etc. If you click on modify show material property design data, you can see the concrete cube compressive strength, which can again be edited as per user's convenience. We'll press OK, and we have the HYSD 415. We can see again the data. Now we'll define another HYSD 415. We'll go for the HYSD 500 now. We'll click on add new material. So we have the region India. For the material type, we'll go with rebar. And we have the standard Indian again. And for the grade wheels, you can see that ETABS has a directory of all the rebars available, commonly used. We'll select with HYSD 500 and press OK. You can edit the material name. Again, you can change any of these values if you wish. You can go there and change the yield strength, tensile strength as per your convenience. We'll press OK. You can see HYSD 500 has been added to our directory. We'll press OK. Now, next step is to define the sections we will be using in our project. So what are some main sections that we use in our project is beam, column, and slab, and shear walls, if there are any. So under the section properties, the very first option you see are frame sections. So frame sections are columns and beams. So you can see ETABS has again predefined some sections for you to use, but we will ignore all of these and we will add another section as per our own standards. So we'll click on add new property. Now for the first is section shape. You can select any shape, whichever you want to define. We'll go with concrete rectangular as of now. And it also shows you frequently used shapes. We need the concrete rectangular. We'll select this rectangular section. You have a window open in front of you. So we'll define a beam, for example, say of 300 by 450. We'll name it B 300 450. Material, we have defined M30 for the beam. We'll give the depth. Now, the next important thing is we'll go to reinforcement, modify show rebar. And since we are designing a beam, we'll go with the M3 design only. And for the longitudinal bars, we'll select HYSD 500. And for the confinement bars, we'll go with HYSD 415. We'll press OK. And you can see the beam is defined now. We'll press OK. The properties here, B300 by 450. Next, we'll define a column. We'll go to add new property. Again, we'll select a rectangular section. And we'll name this as, let's start with the size 300 by 500. Material is M30 as we have defined. We'll give the depth as 500 and we'll give the width as 300. Now you can see the reinforcement data is also available. Again, we'll click on modify show rebar. Since we are designing this, has to be designed as a column, we'll select the TM to M3 design, which is for columns. Longitudinal bars, again, we can select HYSD 500, up to you, whichever you want to use. Now this shows on the Now as we come down, it shows number of longitudinal bars along the 3-direction phase. So if you see on the screen, this is the direction phase. It says the number of bars is 3, and on the along the 2-direction phase it says 5. These are all. So this is where you set a standard for designing in future, just to tell the program on an ideal how many bars will be present. So you can change them again. So for example, if I change them to say 6 and change these to 3 and press OK, now you can see the changes are also reflected here. So we'll go back to there and change it back to 3. You can select the longitudinal bar size and area, again a typical corner bar size and area. You can select a typical standard confinement bar size and area. You usually work with 8. Press OK. You have a column defined. Press OK. And is press OK. Perfect. So we have a beam defined in front of us, and we have also defined a column for our modeling. We'll go back to define again. Then under the section properties, we have other things also that we can define. We have tendon section, slab section, deck section, wall section. We'll define a slab section for our model. Again, we'll go with add new property. Then we'll give this as S150, 150 mm, 150 dictating the thickness of the slab, 150 mm. We have defined the thickness. Now the slab material, we have M30, again concrete. Now for the modeling type, you have few options available. You have shell thin, shell thick, membrane, and layered. Now membrane type of slab is only used when you have just in plane stiffness, and when you want all of the loads to be transferred from slab directly to the beam. So ETABS transfers the load in trapezoidal or triangular manner. Slab does not take any of the loads, directly transferred to the beam and through column, then to the columns. Now, for example, if you want the out of plane stiffness also, if you are say designing a shear wall or a retaining wall, then you'll go with a shell thin or shell thick modeling type. And in this modeling type, you have to make sure that you do the meshing of the slab. So we'll go with the membrane. And for example, if you want to use, if you want to apply a slab, one-way slab somewhere, so you can also define another property and just take this, use special one-way load distribution. It will define it as a one-way slab. You press OK, the slab is also defined. Coming back to the define. So then we have diaphragms, pier labels, spandrel labels for your shear wall. Then there are multiple things you can define. You can define functions, response spectrum, time history, which will be explained later. You can define the mass source of the building. Let's see the mass source. One mass source is already defined by the program. We'll go on modify, show mass source. Now there are options, and you can select through which way you want to define your mass source. We'll go with specified load patterns. And since we have not defined any load patterns as of now, we'll come back to the mass source definition once we have defined the load patterns. We'll press OK. And then coming back to the define, then you have P delta options if you want to do a P delta analysis. Then is the load pattern definition. So we'll click on load patterns. Now this is where you will define a load patterns, which all load patterns you will be using. So we have dead and live already defined by the program. Now, for example, if you want to apply a brickwork load on in your model on the walls, we'll define a load pattern under which the brickwork load will fall. So we'll give the name as brickwork, and the load pattern load type will be dead load. Self-weight multiplier will be 0, and we'll add new load. You have now dead, live, and brickwork. Then if you want to say start with you also want to define the EQX load, which is the earthquake load, lateral load for the X direction for the static. So we'll name this as EQX. Now for the type, since it's a lateral load, we'll select seismic. And for the lateral load, we'll select the IS code, which is the IS 1893 2016. And we'll click on add new load. Then we also want to define for the bidirection. We'll simply change it to EQY and add new load. Now we want to modify the lateral load. We want to apply the time period and response reduction factor and everything. We'll go to modify lateral load. Now you can see the direction and eccentricity. Since we are doing it for the X direction, we'll uncheck everything. Now it is only going to be applied in the X direction. Then you have the story range, from which story to which story you want to apply the lateral load in your model. Then you have the response reduction factor. Then you have the seismic zone factor, zone 1, 2, 3, 4, and accordingly you have a factor for that. Let's go with zone 4 since I'm in Delhi. Site type, we can define the site type, and we also have the importance factor according to the code. We can define this. So there are three ways to define the time period for your analysis. It can either be approximate, then the program will calculate once you run the analysis, and third is the user defined method. So which is that formula mentioned in the code for usual generation calculation 0.09 h by root d. So let's say we have a time period of 0.3 seconds. We'll press OK. And similarly, we'll come for the EQI. We'll go for the modify lateral load. We'll uncheck everything, just the bidirection. We have the same top story, bottom story, response reduction factor. We'll change the zone to zone 4. And for the time period, we'll again give it 0.3. So we have defined dead load, live load, brickwork load pattern, EQX and EQI. We'll press OK. Coming back to the define. So we have few more options available. We have the load cases and we have the load combinations. So what is load cases? So load cases is, so these cases are the cases that will work on the model when you run the analysis. We have a dead load, we have a live load, which is a linear static. It shows you a type of cases that we have a modal load defined by the computer. It is up to you if you want to use it while running your analysis or not. You usually do for the modal analysis to check the modes of the building. Then we have the brickwork, and then we have the EQX and EQI, which we just defined. We'll press OK. Coming back to the load cases, all of these load cases are customizable from here. If you'll see, we'll click on modify showcase. It will show you the name. It will show you the load case type. Again, if you're doing a non-linear, say if you want to define a non-linear case, you can select a non-linear and define the case as per your convenience. And then it shows you load type and scale factor and everything. We'll press OK. Then we'll go to next is load combinations. So if you want, so when you run the analysis and for your results, if you want to check for some load combinations present in the code, so we'll start a basic combination where we'll combine all dead load and live load. We'll go to add new combo. We'll name this combination as dead load plus live load. Combination type, we'll keep it linear addition. There are other options available: envelope, absolute addition, SRSS, and range add. So we have dead load there. We'll add live load and we'll add brickwork. So we have dead load and live load, and this when this combination is triggered in the analysis, ETABS will add all of these loads, a linear addition, and show you the results, show you the stresses and moments because of this combination. We'll press OK. You can see a combination has been added. You press OK. Then you have the next. Then we begin to the drawing phase of our structure. So we'll start modeling the structure now. Under the drawing draw options, you have shape, select object, draw joints if you want to draw a joint any specific place, draw beam, column, floor, draw links, tendon, basically each and everything you wish to draw in the structure, you have this under this menu. When you come down to the menu, there is a snap options. So since we are working with grids, we want to be as accurate as we can while placing our objects, and it would be good and easy for our analysis and drawing that it falls on the grid. So you want to snap it to the grid, right? So this is the snap options for the grid. You can select and unselect, deselect any of the option. Whichever option you select will be applied to the grid. You can select all. For me, this is what I like to use. Yeah. So this is what I like using. I want intersection where my grids intersect. I want lines and frames, snapping it my objects to line and frames, edges, perpendicular projection, joints, line ends, and midpoints and grid intersections. I'll click on apply and OK. Now let's start with the drawing. Now coming back to the menu, that was shortcuts available for you to drawing. We'll come to the plan view, and through these two arrows available on the menu, you can toggle the floors or the elevations. So I will go to the ground floor. You can see it my shows plan view ground floor, and it shows me the elevation of the ground floor. So let's start with placing columns. We'll come here, which is the second, third, fourth, fifth option from the top. It says grow quick draw columns. We'll click on here. You'll select the property of the column, which we have just defined, column 300 by 500. You can close this window, and you can place the column on the grid intersections. Now, this is one way of drawing columns. For example, if you have a very simple project like this and you want to draw columns on every intersection of the grid, you'll just left click, you'll draw a window throughout the project, keep holding the left click, and you'll release. Now you can see all of the ETABS has drawn a column on every intersection of the screen. Now, if you are in a command and you want to get out of a command, whether it be a draw command, select command, or any command, just press escape and you will exit out of that command. You will come back to the normal one. So next we will draw the beams. This is the third option available from the top. So there are two options to draw beams. So we'll go first, select the first one. Again, we'll select the property of the beam, which we have just defined, B300 by 450. We'll close this window. So we want to draw a beam from this column to this column. Left click on this, release the left click, go to the other column and press left click. You see the beam is drawn. Again, if you want, so now you must be, so now the last point on where we draw the beam was here. So now this stays in continuity. So you can keep on going like this. You go from here to here, then you go from here to here. Now, for example, if you want to draw at some other point, so this time you don't have to exit the command. You just want to exit this drawing point. You'll right click, use the right click of your mouse. You can see that it disappeared. You'll go to the desired point where you want to draw a beam. For example, E5, again left click, release the click and draw the beam. Press escape to exit the command. Then we have the next option available, quick draw beams. So we'll select the property again, very important. Make sure you select the right property before drawing. This also works similarly like a column thing. We'll draw a window like this. And you can see it has drawn beams similarly. And it will also place a beam automatically between two columns. Just hover your mouse on the grid line between two columns, left click, and it will place the beam. Now next, let's draw slabs. So again, you have two options available to draw slabs. The first one is the edge option. First, again, very important, you'll select the property of the slab. We have S150 with us. So for this, you have to select edges on which the slab will rest, the four edges of the slab. So for example, if you want to draw a slab resting on these four columns, A5, B5, B4, and A4, we'll start with edge A5. Then we'll go to edge B5, left click. Then we'll go to edge B4, left click. Then we'll go to edge A4, left click, and come back to the edge A5 where we started. You can see the slab is there. The other option is when you have simple square or rectangular slabs, you'll just select this option. You select the property S150 and you will select the first edge of the slab and left click, keep holding the left click, and you can simply draw a window and take it to the final edge of the slab, connecting all four edges, and the slab is drawn. Very simple. And now, so ETABS has this special function when you have defined the slab as a membrane, and to save your energy, obviously, if you have multiple slabs, a similar flow, you don't want to draw a slab or for every intersection. What you can do is you can simply draw a big window, draw a slab across the whole, and similarly, we'll draw another here, one slab, and again here. So we'll press escape to come out of the command. Now you can see that this is right now as a single slab, and technically we want this slab, we want this to be divided in 1, 2, 3, and 4 parts. So when you will run the analysis, ETABS will automatically divide it into 4 parts to show you before, not to show you without running the analysis. We'll go here. It says object shrink toggle. Oh, we'll go here. Sorry. We'll first go to set display options, and under the display options, you have other special items under which you have the shell analysis mesh. We'll select this. We'll press OK. And now we'll go to object shrink toggle. When you click this, you can see ETABS has automatically divided all the slabs. So we'll press shrink toggle again, coming back to normal. We'll go to set display options and we'll untick shell analysis mesh as of now. So if we'll come to the base. So we have the base where we are the joints of the columns. You can see on the right hand of the screen. When I'll select the column, it will reflect on the left side of the screen that which object I have selected. I'll press escape to come out of the window. I'll go back to the plan view. I'll select all the columns, all the points of the columns. And now we want to assign, for example, any restraints to. So we want to, for example, if we want to assign restraints to these points. So we'll go to assign under the join and we'll select restraints. We want to get them fixed. You want to get them pinned or you want to get them free. You go to restraints. You can either enter them, you can either restrict them manually, or we have some options available predefined. We'll go with the pin, we'll go with the fixed and press apply. And now if you'll right click on any of the joint, for example, a column E joint created because of column E5, we'll right click. You can see the restraints UX, UY, UZ, RX, RY, and RZ. So coming back to ground floor, now so for example, if we have a long structure, big structure, and we don't want to draw these slabs again and again. We don't want to draw the beams. So what we will do is we will replicate everything. So before we begin with the replicate, let's also assign some loading to the slab and to the frames wherever it's required. So to assign the loading, so we have the assign function again here, assign for joint, assign for frames. If you want to assign some section property to a selected frame, if you want to assign a property modifier to the frame, releases, end length, offset, insertion point of the frame, local access, anything. Then you under the shell, you have similar options for the shell. You have the mesh options also available. And then we have the loads option. For the joints, we have force, ground displacement, temperature. For the frame, we have point distributed temperature. And for the shell, similarly, we have uniform, non-uniform, and temperature. So let's start with analyzing. So let's start with assigning some loads. So for example, if I want to assign a dead load of say 4 kilonewton per meter square, I'll select all these slabs. I'll go to assign shell loads, uniform, and you can see the load pattern name. We want this dead load to fall under the pattern of dead. We'll input the load we want to assign. Then we have 3 options. We can either add this load to, so for example, if I have defined a dead load of 4 kilonewton per meter square earlier on the slab, and I want another 4 kilonewton on the slab. So I can either add it to existing loads or I can replace it. For example, if I had 4, now I want 5, I'll just input 5 and replace. Or if I just want to delete, I can just select delete and it will delete all the existing loads on the structure, on the selected slab. So let's go with replace load. Direction will be gravity. Press apply. You can see if I select this slab, right click on any property, right click on any object that you have defined to see the properties of that object. You have the geometry of the object available. You have the assignments. So we have the section property. Have we defined a diaphragm? No. We can assign local property modifiers, which will be displayed here. Then there's the cardinal point, joint, offset. You have any area, mass, etc. Anything on like no. Then you have the loads, and you can see we have a uniform load of 4 kilonewton per meter square. Direction is gravity. We'll press OK. We'll select the slabs again, and we will assign them a live load. Similarly, if you want to see if you have selected or if you want to cross check the number of elements in your model again and again, when you select object on the bottom left, you can see it shows you how many shells, how many edges, and how many frames or column you have selected. So for now, we have selected 7 shells and 28 edges. We'll go to assign. Again, we'll go to shell load, uniform, and we'll change the load pattern name to live, and we'll change it to 2. And we'll press apply, press OK. We'll select this slab, and you can see the load pattern. We have dead 4 kilonewton per meter square, and we have a live of 2 kilonewton per meter square. Now next comes if you want to assign any loading to the frames. Now frame loads are usually brickwork loads. So we'll select the frames where we want to assign the load. For example, we'll select these 2 frames. We'll select 2 frames on each edge. So on the left hand side, you can see 8 frames are selected. We'll go to assign. We'll go to frame loads, distributed, and we'll change the load pattern name. Since it's a brickwork load, we will change it to brickwork. Then replace existing loads. You can predefine trapezoidal loads. You can give the distance and you can give the load, or you can just give a uniform load value. Let's say we give this 3 kilonewton per meter. Can be anything. For a 1 meter parapet wall, you can calculate if it's a 230 mm, you'll get some value around 5.14. So it's just a random number. We'll click apply and we'll press OK. Now let's come to the 3D view to get a better idea of the brickwork load we have applied. You click on the window, you can see 3D view is highlighted now. You'll go to display and you'll go to load assigns now. You want to see the load, so you'll go under display. You want to see the load assigns. You'll select the load assigns, and you want to see the load assigns of frames. You'll select frames. As of now, you can see the load pattern is dead, so you can't see anything because we haven't applied anything under the load. We'll select brickwork and we'll press OK. And you can see we have the brickwork load of 3 kilonewton per meter acting in the gravitational direction. Now to come back to the undeformed or like plane structure view, simply go to display and click on undeformed shape. Coming back to the plan, now coming to the replicate. Now we wish to replicate all these loads and these items, these objects we have defined, the beams and the slabs and the columns, to the floors above. So what we will do is we will draw a window from right to left, and we will select each and every object present here. As you can see on the right hand side, I have selected all of the objects. On the left hand side, it shows you 25 joints, 65 frames, 7 shells, and 28 edges. We'll go to edit. Since it is an edit command, we'll go to replicate. Now you can there are 4 options for a user to replicate. You can replicate a beam, shell, or any object you can replicate. You can replicate them linearly. You can replicate them radially, or you can give them a mirror object, mirror image, or the story wise, which we are going to do. We have the ground story in front of us. We want to replicate to first, second, and roof. We'll select first, second, and roof, and so you can see modify show replicate options for assigns. This will show you what all is selected by you. You can tick or untick any of this option if you don't want it to get replicated on the floors above. For the joints, you have joints, you have assigns and loads if there are any. Then similarly for the frames, you have the assigned properties of the frame, you have the loads on the frame, and you have any overrides if you have on the frame. If you wish that you don't want to transfer the load, replicate the load, you can just unselect this here and it will not replicate the load on above floors. Similarly, you have for shells and obelisks if there are any in the model. We'll press OK. We'll select first, second roof, and we'll press apply. You can see on the right hand side of your screen, all of the objects have been replicated. We'll come to the plan view. This is the shortcut to access the plan view. You have set 3D default view. You have plan. We'll go to plan. Let's go to second floor to check. We'll press OK. We are on the second floor. We'll select this slab. You can see a dead load of 4 kilonewton per meter square and a live load of 2 kilonewton per meter square. So we have the structure ready in front of us. We have assigned We have fixed the joints at the base of the structure. We have applied a dead load of 4 kilonewton per meter square and a live load. And we have also defined a brickwork load, which is replicated throughout. So we'll go to 3D view. Again, we'll go to display, load assigns to check. We'll click on frame, brickwork, press apply, and again rotate the structure, and you can see the loads are applied. This is on the, again on this option menu, 3D plan, elevation, rotate. You also have the undeformed one. So almost each and every command can be made available to you on your this toolbar function. So if you go to options, so you can first, I'll go with reset default toolbar. This is how your default toolbar will look when you will first open ETABS. You have a new model option. You have open, you have save, undo, redo, refresh the window, lock the model. Now, what does locking the model means? We'll come to the window plan view. And for example, I'll click on lock the model. So now you won't be able to make any changes in the model. For example, if you select and you press delete on your computer, you'll keep pressing delete. You won't be able to make any changes to the model. You cannot draw anything. You basically cannot do anything. Model is locked. We'll unlock the model. Then you have the play button, which means run analysis, which we will do shortly. Then you have some zoom options. Then you have some 3D plan similarly. So if you right click on this blank space, you have other options that can be made available to you. If you don't want to go to the menu again and again, you can select the assign frame tool button. Then you have the assign frame options, frames, assign frame section, assign frame releases, which is similarly here, right here, frame section, frame releases. And you can select for assign, join, assign shell, define, edit, view, cut, and everything up to you. So also you can move these as per your convenience. So coming back to the modeling. So we have defined the load patterns. We have defined the earthquake load. And also we have defined the uh, brickwork load, and we have replicated. So let's start with running the model now. So for that, we'll go to analyze. And first is the check model. So what check model? We'll click on check model. We have the tolerance. We'll select all. It will check the joints. It will check if any frames are overlapping or not. It will check if any shells are overlapping or not. And it will also check for meshing of the stories and everything. So this will basically go, so the ETABS will basically quickly go through your model and will let you know if the structure is unstable through any of these options. For example, if a beam is overlapping a beam, or if a shell is overlapping a shell, or if they're too close or not properly joined with each other, because of which the loads will not get transferred. So ETABS will check all of that. We'll press on OK. So see, model has been checked. No warning messages were generated. So if there is any warning message, let me do one thing. So again, we'll come to edit option. We'll come to select if you come to the left hand side of the toolbar menu, you can see the second option as reshape object. So we'll select this. So what does this option do is, if you want to reshape any object in the model, for example, if I select this slab, you can see it is now showing me 4 edges of the slab through where I can reshape them. It also have the edges, which you can do like this. So I'll start with here. I'll left click on this, keep clicking it, drag it down, and you can see it has the reshape the object. Similarly, for a beam object, I'll just select this edge and do it. Now, for example, if I want to again rest it on the beam, I'll just simply select, drag it to the beam and release. So now you can see my beam is not connecting properly, and I'll draw another beam on top of it. I'll draw a beam from here to here. So we are working on second floor right now. And now I'll go to analyze, check model, select everything, tolerance 1 mm, press OK. Now you can see second floor, second defines second means second. B41 and B40 are overlapping with each other. Check selected objects. It is showing you that there is an error. So B40 and B41. Now to check which one is B40 and B41, we'll go to view and we'll go to set display options. And since we are dealing with objects right now, we'll select objects. And for the frame, we have the labels. We'll press apply. You have the labels. There you go. And this is beam 41 and 40. So I'll correct this. I'll delete this beam, I think. Perfect. So again, we'll go with the set display options. We'll untick the labels, press apply, and analyze, check model, and check. You can see model has been checked. No warning messages were generated. Now let's run the model. We'll go to analyze again, and we'll click on set load cases to run. So now in front of your screen, we have all the load cases that are going to run the model. So we have a dead load case, which is linear static. It shows you status and action, and status as in it is not run right now, and action means that it will run it. So if I click on run do not run case, it means that it will not run the case when we run the analysis. Then you have the live load, then you have the modal analysis, then you have the brickwork, EQX and EQI as you define the lateral loads. Then all of the are run. We'll click on run now. So now the ETABS asks you to save your model. So whenever you're working on your model, it is recommended keep saving your model. And whenever you run the analysis, this will ask you to save the model and for the first time. And next time when you run the analysis, ETABS will automatically save the model in your selected destination. So we'll name this try one. We'll save. So now there were some errors in the model. So we forgot to define the mass source. So we'll unlock the model. We'll delete all the results. We'll go back to define, and then we'll go back to the mass source, which we did on the first step. We'll modify the mass source, and we have selected the specified load patterns that we want to be included in the mass source. We'll add dead load. Then we'll add live load, and then we'll add the brickwork. We'll select the include lateral mass, and we'll select the lateral mass at story levels. We'll press OK. Mass source has been defined now. Now we will run the model again. Now you can see the model is successful without any errors. So on the right hand side, you have the deformed shape. If you will hover your mouse on the joints, you can see the deflection in them. Similarly, if you'll come to the plan view and you want to see the bending moment diagram of the beams, you will go select this option, which is display frame pier. This is the shortcut, but it is under display options. We have forces, stresses, and diagrams. We'll select frame pier spandrel link forces. We'll drag this window here. We'll select moment 3-3 for the dead load. We'll press apply. You have the bending moment diagrams. If you want the values also displayed, you select this option, show values, and press apply. You have the values. Now, for example, if I'll right click on any of the beam object, for example, if I want to see the bending moment diagram or study the bending moment diagram and shape force diagram, I'll right click on the beam object. And on this window, you have the bending moment and shear force diagram. And you can move the cursor to study the diagram at a specific location of a beam and to check the bending moment and shear. Done. And similarly, we can see the shear. Now we made a combo of dead load and live load. We'll go to combo. We'll select the combination. We'll select the moments and press apply. Now you can see these are the moments because of the combination. So for example, if we'll select the same beam again, you can see the moments. The maximum moment we are experiencing is of 54.5357. If we'll come back to the case again for the dead load, press apply. You can see the difference in the moment. Now it is 55. Now, if you want to check, so we'll come to the window and make this undeformed. Now, if you want to check the axial force in the columns, we'll go to the elevation. We'll click on elevation. We'll select any elevation. For example, select elevation B, press OK. And then again, we'll go to display, forces stress diagrams, frame pair, and we'll select the axial force. Again, we can select the combination, show values. We'll press apply, and you can see these are the axial force in the column. Again, right click, and you can see the axial force. We'll go back to the plan. Let's go to the ground floor. So now the next option is, if you want to see, if you want tables of your results, if you want to see, say, joint forces. So we'll go to the plan and we'll go to the base. So these are your joint, and if you want to see the joint reactions on the base, the first thing is you want the joint labels so that you will be able to identify them. So we'll go to set display options and object assignments. So we are dealing with joints, joint assignments. We'll click label and press apply. You can see 1, 2, 3, 4, 5, 25, 8, 12, 16. The joints are there. Next, we'll go to display and we'll go to show tables. Now, under the show tables, you have a variety of options available for you. You have the model, starting with the model definition. You have the system data. You have the property definition, material property, tendon property, which you have defined. It will show you. You have the load pattern definition. Under the load pattern definition, let's select load pattern definition, autoseismic. Then you have the response spectrum function. We have not defined any yet. Then you have load case definition, connectivity, joint assignment, frame assignment, anything. Then comes the analysis results. So under the analysis results, we have the run information if there are any analysis messages. We have the joint output. We have the displacements. We have the reactions. We'll select joint reactions. Then we have the element output. Then we have the structure output where we have base reactions. We'll select that also. Then you also have the modal information if you want any mass participation, your factors and everything. We'll select these. So we have the load pattern definition for IS 190 selected. We have the joint reactions and we have the base reactions. So we can select the load patterns if you want any. Then we can select the load cases and then we can select the load combination. We'll press OK. Now these are the base reactions. So so we can change the output case here also. For example, if I just want to see for dead load. So for the dead load, this is the base reaction. But let's go to joint reactions. Just a second. Yeah. So these are the, yeah, so we have the joint reaction now here in front of us. There was some error. So we have the base. On the base, we have the label 1, and you can select the output case for which you need the joint reaction. You can select dead load, live load, combination, EQX, EQI for any specific. For example, if you want to check because of the EQX, we can see for the base joint one EQX, we have FX, FY, FZ and moment. And similarly, we have for the combination, again, for the combination, dead load and live load, we have the FX, FI, FZ and MX, MY and MZ. If you want to filter this, we can go to the output case. We can select the combination and exit. And now you have all the base reactions available for the joints on the base. So 1, 2, 3, 4, 5, 25. So we have the labels here. We have the output case we just selected, and we have the forces and moments with us. We'll press done. We'll come back to the model. And now we want to see the shell stresses. So we'll press on display and forces stresses and shell stresses. And for the combination, for this window, we'll press apply. And when you'll hover, you can see the F11 on the shells. And similarly, M11, which will be 0. And F22, again on the shell. Now, for example, if you want to work on your report and you want to generate a report, ETABS also give you the option to generate a report. It is under the file option, and you have the create report option. We'll explore this later. Let's first come to the design now. So under the design, you have various options available. You have a steel frame design. You have a concrete frame design, then composite beam design, composite column design, steel joist design, shear wall, and concrete slab. So we'll go with concrete frame design. Under the view revised preferences, you can see you can select the code multi-response case design. You can edit these values. You'll press OK. We'll go with the default values. We'll come back to design, concrete frame design, and we'll click on start design check. So now on the screen, you can see the reinforcement. I'll select the rubber band zoom. Now for the beam, you can see 3 values on the top and 3 values on the bottom. So these 3 values on the top tells you the top reinforcement required on the left hand side, which is 1198, in the middle, which is 308, and on the right face of the beam, which is 1171. Similarly, for the bottom reinforcement, if you select a beam, right click on the beam, you can see the combination, you can see the location, you can see the top reinforcement, and you can see the bottom reinforcement, and you can also see the shear. Now under the details, you can see the flexure details of the beam, which ETABS has computed. You will see basic details of the beam, the level, unique name, section ID, everything. You will see the section properties, material properties, which were assigned by you, design code parameters. Then you can see the required rebar, the rebar because of the moment. And then you can see the design moments calculated by the program. You have the shear details with you for further studies. And then you have the envelope. Now, if I want to check, we'll go with the regular zoom, restore full view. Now we'll come to the second window. We'll select elevation B again. Let's go with C. And now we have run so once we have run the design, and if you open another window, results won't be there. That doesn't mean you don't have to design it again. You'll just go to display. You'll just go to design, concrete frame design, and you'll check display design info. On the window, on the right hand side window, I selected this option, and I'll select design output total longitudinal reinforcement. I'll press OK, and you can see the column reinforcement is also visible in front on the screen. So I'll select this column, which has a 4024 reinforcement required on the from base to ground, then 4811, and then 4834 and 4766. I'll select this column, right click. Again, you have the station location, longitudinal reinforcement, and everything. You'll go to details. Then you have the flexure details of the column. It will show you the basic details, similarly like beam, section properties, and everything. You can see the design moment, MU, M3, the minimum, the rebar, and also the rebar percentage. As you will scroll down, it will also check for sway or non-sway frame. ETABS will also check for that. It will calculate the Q factor. It will tell you which K it has used, and it will show you if there are any additional moment reduction in this or not. And it will also calculate the additional moments if there are any or not. You can see that KL depth ratio did not exceed according to the code, so there are no additional moments. You have the share details on the next page. You have the same starting details, material properties, everything, additional moments if there are any. Then you have the shear design for VU2, VU3, design forces that were used, capacity shear, design basis, shear rebar design. Very simple. You have the joint shear details, BCCR details, and the envelope. Now, for example, if you want to see the shear details of the beams on this page only, you'll come back to this menu, this window, plan view. You'll go to design, concrete frame design. You'll select display design info, and you'll select shear reinforcing. We'll press apply, and you can see it now shows you the shear that is required in the beam. So that is 1038, 876, 1055. And while design, you can automatically give this stirrups as per your convenience and the requirement. Similarly, if you want to see the requirements of the column, you want to see the reinforcement percentage in every column, and to check if it is exceeding the allowable limits or not, we'll select total rebar percentage. We'll come select this window and we'll press apply. You can see the total rebar percentage. We have 2.68%, 4.8, 4.31, and so on. So we are done with the analysis. I've shown you the basics of design, how you can check the flexure details, shear details of columns and beams. And now let's come to how you can use this create report option for your projects in further for future if you want something for your personal use. So you can go with show project report, which is a basic generated report by ETABS. You have a show summary report, again generated by ETABS. You have add user report again, and then we have an advanced option, add new from XML content file. So we'll go with show project report. So this is the project report. It will show you table of contents, properties, assignments, loads, analysis results, and everything. It will show you all the tables, how they are differentiated. It will show you the grid system which you have defined. It will show you the connectivities. You can select or deselect them while making your own report. You have the properties, assignments, loads. You have the IS 1893 auto seismic calculation. It will select 100%. You can see period calculation method was user specified. Point 3, I defined the zone factor, response reduction. It shows you the seismic response spectral coefficient. It also shows you the weight, the base shear. And as you scroll down, it will show you the display, how the loads were applied in the report. It will show you the loads on each floor. Then you have the for the y direction, it has calculated the coefficients and everything, showing you the loads again. Then you have the load combination definitions and so on. So you can close this. So we'll unlock the model, and you can see all the results are deleted. So we have almost explored each basic option for you to study. We have the views and everything. We have under the define. We have defined a mass source, load cases, load combination, and now let's see how we can draw a retaining wall or a shear wall. Let's start with the shear wall. Now, for example, I need a shear wall on this edge from B to C and C to D on every floor. I'll select the 3D view. I'll come back to this. I'll go under define, and I have to define a property for the shear wall. I'll go section property, wall section, add new property, and I'll give this SW230. I have a wall material M30. I have a modeling type shell thin, and I'll select S230. Again, I can select shell thin or shell thick, and I'll press OK. I have a shear wall 230. You press OK. Now I want to draw a shear wall. I'll come to this window, plan window, where I will draw the shear wall. And I'm on ground floor right now. I'll go to draw, and I'll go to draw wall objects and I can select either of these options, or I can come to the shortcuts available here. Here you have a quick draw floor, you have a draw walls, and you have a quick draw walls. We'll select draw walls. Type of area, it is going to be a pier. We will keep it simple. I'll select the property, share wall 230. I'll again left click from here, B to C and C to D. Now I'll exit the command, come back on first floor. Again, select that option, share wall 230. I'll draw another. You can draw like this, or you can just select the wall and replicate them as I taught you. Now I'll come to the 3D view. I'll rotate this to give you a better picture of the wall. So this is your shear wall now. You can see I have the elements. So next is, so we have to define this as pier or spandrel. Since it is similar on every floor, there are nothing different about this. We'll go to define. We'll go to section properties, and sorry, we'll go to pier labels, and we have a pier label defined P1. We'll press OK. We'll select these walls. Yeah, and then we'll go to assign. Since we want to assign something, we'll go to shell, and we'll go to pier label. We'll select the pier label. We'll press apply. You can see P1 has been assigned. Now, before we run the analysis, we have to mesh the wall. So we'll again select all the walls. So one way is selecting again and again. So for example, if you want to reselect something that you have recently selected. So for example, I'll select all these walls. And so I selected right now 8 shells and 32 edges. And I want to select these again. I've unselected them. I'll go to select and I'll click on get previous selection. The program will select those walls automatically. Now next step is to mesh the wall. We'll go to assign again. Since we have to assign a meshing, we'll go to shell, and under the shell we'll go to wall auto mesh options. So you can default is no meshing for straight walls. The other is mesh objects into vertical and horizontal. You can define the values. Let's give them 4 in vertical and 5 in horizontal. We'll press apply, and then to check the meshing of the wall, whether it has been done or not, we'll again go to set display options. Under the other special items, like the previous time, we'll click on shell analysis mesh and we'll press OK. Now you can see the wall is meshed into 4x5. So now this is how you measure wall. So we'll select the wall again. So the other way to select is we'll go on select, and we'll click on object type. So we have all the objects available. We'll select walls, select, close. And for example, if you want to delete this, we'll just click on delete. And you can see the program has deleted the wall. We'll undo the delete, Control Z. This is not working, but no worries. We'll draw the wall again quickly. Now, so for example, you don't want to draw or you don't want to replicate the walls. So the next option is on the right hand side bottom, right? So this is the 1-story option. We are working on one story, so any change that we do will be reflected on the specific story. We'll select all stories, so any object we'll draw will be reflected on every story. So we are working on now all stories. We'll go to the wall, shear wall 230 is selected. We'll draw a wall again. And you can see it has drawn the wall on all stories. So we'll come back to one story again so that we don't make any changes on all stories. So I showed you how to mesh it. So now for the analysis, we have to break the wall. So before breaking the wall, we'll assign the pier. Then we'll go to select, get previous selection. Then we'll go to assign, shelf, and then we'll go to edit, and then we'll go to edit shells, and we'll go to divide shells. So here we can divide the shells as per our own convenience. You have options available. We will divide them 5 by 5 and press apply. And you can see that they have been divided. Similarly, you can select the joints of the walls and you can assign them restraints if there are any. We'll select them, assign, join, restraints, fixed. We'll press OK. And the restraints have been assigned. So we have learned the modeling of wall, frames, beams, and we have also learned how to check the forces in the elements and how to create a report. So if there are any doubts regarding this before we start with the SAP 2000. Vivek sir?
Yes, Lakshay.
Yeah, so you can take it from here and in the SAP 2000 explain the remaining.
Yeah, thanks, Lakshay. I think there is
Tinkle, do you
one
have a doubt?
question.
Yeah. If there are any doubts, you can unmute and ask directly. Yes. Yes, yes, Vinay. So when you define, so as I explained earlier, so for the shear wall, we use the material, we use the model type as shell thin. When you are defining a shell thin element or a shell thick element, then you have to manually mesh those elements. But when you are defining a membrane, then ETABS will automatically break those elements and do the analysis wherever required. For the membrane, you don't need to mesh them manually. When you're defining them as a shell thin or shell thick, when you have out of plane stiffness also, then you need to mesh them manually. Point. Yeah. So I mentioned a time period of zero point 0.3 second, but that was just a number. The according to the code, it is 0.09 h by root d, where h is the height of the building and root d is the dimension of it if in x or y direction. So you can use that formula, and whatever time period you get that from that formula, you will use that to input it. Oh, Welcome. Any other doubts? Okay. Vivek, so you can start with the sub 10.
Yeah, yeah.